Hello, chemists and biochemists. Today, what I want to talk to you about is stereospecificity. Stereospecificity with respect to enzymes. So, how selective are enzymes when it comes to different stereoisomers? So, what I wanted to show you first was just a little bit of a perspective on the different forms of molecules. On the left-hand side of the screen, what you'll see here is you'll see the amino acid, the amino acid alanine specifically shown in the L formation, the levorotary formation. On the right-hand side, we've got our dextrorotary form, our D-alanine. Now, what's important to know is that when it comes to utilizing an amino acid as a part of a protein, the L form is the form that is most relevant. Virtually every circumstance you're going to be implementing and utilizing that L form of any amino acid. The D form is, well, your less significant one. Now, what's important to know is that enzymes are selective for which stereoisomer of any molecule that they pick. And I just decided to show amino acids as an example molecule. Now, what I was looking at and what I wanted to share you with, or share kind of as an example, was I looked up this paper and I found that, well, I guess I just kind of have this tendency to think about different stereospecificity as kind of an absolute, like, it will not bind, an enzyme will not bind to the D form of the molecule if its preference is the L form. But this paper right here from back in 1967 looked at the enzyme chymotrypsin. Chymotrypsin is what is known as a serine protease. So it's an enzyme that what it likes to do is find a peptide and cut that peptide. And so in this paper, what the researchers and the authors did was they investigated how does this chymotrypsin process different substrates. And one of the things that they found was that when they had shorter substrates, so these short peptides, and think about them as a couple of amino acids long, compared to longer peptides. So I just kind of like to think about it as a peptide that was about 3 amino acids was a short one, and then one that was about 7 or 8 amino acids as the longer one. So when you gave this alpha chymotrypsin that 3 amino acid long peptide, it was able to process it, whether or not you had the L or the D form of that molecule. But once you got to longer peptides, there was a preference for that L form over the D form. So to extrapolate that outward, as the peptide would get progressively longer and longer, if you're dealing with the D form of that molecule, the enzyme is going to have either less affinity for it or be able to catalyze the reaction at a much lower rate. So when you think about stereospecificity, it could be a matter of the enzyme has virtually no affinity for that substrate if it's the wrong stereoisomer, or it's going to be able to bind it, but it's going to catalyze the reaction at a considerably lower rate or at a rate that just begins to steadily decline over time. All right, well, I hope this was helpful and have a good